Okay, so this again is another torque is I alpha problem, right? And now we've got the radius. Okay, so this is good, right? This is our mass. And so the first thing I guess I'll do is I'll find I. I is 1/2 mr squared, right? So 1/2 351 times 2.1 squared. Okay, so 0.5 times 351 times 2.1 squared. And I've got 773.955. And I'm going to store that in I. Okay, so now we've got equals. Okay, slows to a halt. So it's spinning, it slows to a halt in so many rotations. So it seems like we've got a Suvat problem there. Okay, but before we can do that, we got to deal with RPMs, right? Okay, so I'm going to go 75 RPMs. I'm going to multiply by 2 pi to get, instead of rotations per minute, radians per minute, divide by 60 to get radians per second. So 75 times 2 times pi divided by 60, and I'm going to store that in the initial velocity. And that is 7.854 radians per second, right? And then it's 11.5 rotations. I got to turn that into radians. So 11.5 times 2 pi. I'm going to store that in S because that's our displacement. 72.257. And that's radians, right? So now it seems pretty clear we got a Suvat, right? Okay, so initial velocity is 7.854. Final velocity as it stops. Displacement is 72.257. And this is radians per second, radians, right? And really what we want is alpha. We don't care about t, so we use no t. So v squared is u squared plus 2as. A is v squared minus u squared over 2s. So that is 0 squared minus 7.854 squared divided by 2 times, what is that, 72.257? Okay, so now for me, I stored that in u, so I'm going to go alpha u. You're going to type that number in if you didn't store it, and then divided by 2, divided by s, for me, is where I stored that guy. Okay. 0.42685. And that's radians per second squared, right? So now I'm just plugging numbers in, right? 0.42685, right? And now we're set. So now we've got, I'm going to store that in A, right? Alpha I is 773 times alpha A. And I get that my torque, when I just multiply it together, my torque is equal to 330.36 meter newtons, right? So I just multiply that together, I got the torque, right? But we want to know the tangential force at the edge, right? So we got the last step, right? First step is that, second step is this, third step is this, fourth step is we got to relate that to a force, right? So that equals RF, right? Well, we know R is 2.10, right? So 330.36 is 2.1 times F. Okay, so I guess we divide by 2.1. Hope to heck we get the answer we got. Okay, so 157.314. And that's newtons. Yes.